For this product examination, we're going to be discussing the Triumph Daytona 675 engine that the Spartan racing team used for 5 years. My name is Ashwin.
My name is Gordon.
My name is Keaton. And I'm Andrew.
So here are the parts that we're going to be discussing in the Daytona 675 engine. So for forged parts, we're going to be discussing the piston and connecting rod. So the piston is created via closed die forging and then is post machined to remove the excess material and create the piston ring clearances and then allow the hole to be drilled out for the connecting rod pin. The connecting rod is then sinter forged as a single piece with both the rod and the cap, and then is post machined to remove excess material, create the rod bearing clearances, and then drill and tap the threaded holes for the bearing cap. The rod is then fractured at the bearing cap to maintain really tight bearing tolerances. The forging process was identified via Triumph's documentation, and the connecting rod exhibits a surface finish that indicates that it was sintered.
All right, for some cast parts, we have the engine block and crankshaft. The engine block is also known as the engine casing. The engine block is sand cast and then post machined several times to hone and machine cylinder walls, face sealing surfaces, drill and tap fastener holes, correct bearing clearances, and drill out oil passages. The case is also cast as a single piece and then split to allow for crank and gearbox access. The crankshaft is die cast and then post machined on a lathe to remove excess material, correct main and crank bearing clearances, and then drill out oil passages.
So this is the camshaft. The main manufacturing process for it is die casting, which is evident through the rough surface finish, as seen between the crevices. So in a die casting, you plant the two parts of the die, you inject, you pull, you eject, and then you trim. During the trimming process, this is where you post machine it to remove the excess material, and also to begin the cam profile. Afterwards, you grind it, and this is where you check for the clearances of the bearing. And then this is also where you finish the cam profile.
So in the process of making gears, they are going through the process of sintering using a sintered alloy. They are being heat treated and then post machined to ensure relief cuts and a uniform tooth profile. And some alternative manufacturing methods for example, for forged parts, you can also cast it and machine it. And for cast parts, you can machine it and forge it, but you can only forge it if it's a simple part. And machining in general is much more expensive and time consuming than any regular manufacturing method. And for sintered parts, you can also machine it, cast it, and use a wire EDM. These are our parts. We have at least 10, but there's a lot more for engines. Thank you for your time. Are there any questions?